In this video, you will learn decimal place values, how to write decimals in different forms, how to compare and order various decimal numbers, and also how to round decimals to various places. So let's begin with understanding decimal place value. Here we have this really long number, and it's important to know what each place value is. So to begin with, we have the numbers to the left of the decimal point. So the 6 and the 2, you can ignore the other parts for now. So looking right here, okay, we know that 2 would be the ones place, 6 would be the tens place. Okay, so we know that, but now the question really is, what do the numbers mean after the decimal point? So working from left to right, the 1 here would be the tenths place. And then the 5 would be the hundredths place. The 8 would be the thousandths place. The 4 is the 10,000ths place. The 0 is the 100,000ths place. Then you have the millions place, and etc. So notice it goes by 10, so tenths, hundredths, thousandths. Here we have 10, 100, so 10,000ths, 100,000ths, and then thousandths would be millions. So it's going like 10 hundredths and then thousands, 10 hundredths, and then another set of thousands would be millions. All right, and this keeps going, so the next one would be 10 millionths, then 100 millionths, then you have the billionths place, 10 billions, 100 billions, etc. All right, so make sure you know your place values. Now with decimals, there are different ways to express these. So you can use standard form, which would be something like this, where you have 62.158403. We also have word form. So word form, we have 62, and then all this extra stuff at the end. So like we said, this 3 would be the millionths place, right? Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. So what we have here is all in blue. This would be 158,403 millions. So we just basically take this number and see what it would be in English. So it's 158,403, and then it's going to be millions because the 3 is in the millionths place. Now we could also write this in expanded form. So expanded form, you would take each number and then write the value of that number. So like 6, for example, that's in the tens place. So 6 tens would be 60. So we'd have 60 plus, and then the 2 is in the ones place. So 2 times 1 is 2. So that's going to be plus 2. So 60 plus 2, that would give me 62. And then the 1 is in the tenths place. So we have 1/10. You can write that as 0.1. The 5 is in the hundredths place. So we have 5 hundredths, which would be written as 0.05. That's 5 hundredths. And then the 8 is in the thousandths place. So we have 8 thousandths. We can write that as 0.008. The 4 is in the 10,000ths place, so we have 4 10,000ths, be 0.0004. And then we have 0 in the 100,000ths place, which you don't need to write 0. So we look at the 3 in the millionths place. So we have 3 millionths, which would be 0.0000, another 0, and then a 3. Right, so let's check that. We have tenths, hundreds, thousands, 100,000, or 10,000s, 100,000s, millions. All right, so we have 3 millions right there. So in expanded form, you could write it like this. And then we could write this in expanded form with multiplication. So basically, we take each place and multiply it by its place value. So for example, the 6 is in the tenths place. So we do 6 times 10. I'm going to put all of this up at one time. Let's explain this. So we have 6 times 10. And then the 2 is in the ones place. So we have 2 times 1. You see that right here. And then this 1 is in the tenths place. So we have 1 times tenths, or times 1/10. So 1 times 0.1. And then the 5 is in the hundredths place. So we have 5 times 1/100th, or 0.01. And the 8 is in the thousandths place. So we have 8 times 1/1000th, or 0.001. 4 is in the 10,000ths place. So we have 4 times 1/10,000th, or 0.0001. And then there's 0 100,000ths, so no need to write that. And then we have 3 millionths. So we take 3 times 1/1,000,000th. So this would be expanded form with multiplication. Now, probably the most common way of writing, other than standard form, would be in what is called fraction form. So what we're doing is we're taking the decimal component and writing that as a fraction. So we said that this 3 is in the millionths place, right? So this decimal component I can write as something over 1 million, because that's in the millionths place. So what I have is all of this right here. All of that would go over 1 million. So the 62 in the front would stay the same. And then that component, the decimal component, you write that as over 1 million. Okay, let's get some more practice with converting from decimals to fractions. So here we have 0.3. So we only have one number after the decimal point. So this would be the tenths place. So what we have here is 3 tenths, or we can write that as 3 over 10. Okay, now let's add a number to the tenths place. Let's now have a 0.31. So this 1 is in the hundredths place. So when I write this as a fraction, we write this as 31 over 100. If you add another digit, now we have 0.317. The 7 is in the thousandths place. So what I have here is 317 over 1,000. And then if we add one more digit, we now have 0.3179. The 9 is in the 10,000ths place. So what I do is I write this 3179 over 10,000. So this here would be my fraction. All right, so make sure you know how to convert from decimals to fractions. Now let's work on comparing and ordering numbers. So here we have 6.2 and 6.20. So these at first glance might look to be different numbers, but in reality, these are the same thing. The zeros at the end do not change the number when you're dealing with decimals. All right, we can prove that because if you just look at the decimal part, so we're looking at the 0.2 and 0.20. 0.2 would be the same thing as 2 tenths. 0.20 is 20 hundredths. These are the same thing because I can reduce 20 over 100. So we've not dealt with that yet at this point in the course, but you could divide top and bottom by 10. That would give me 2 over 10. And that's the same thing as 2 over 10 over here. So the zeros at the end do not change the value. And that's only with decimals. So obviously if you have a 2 without a decimal, then you add a 0 to the end of that to get 20. Those are different. But when you have a decimal, so 0.2 and 0.20, those are the same. And next we have 6.2 and 6.19. And you are told to determine which number is bigger. All right, so right here, notice that we have only one digit after the decimal point for the 6.2, and then for the second number, we have two digits after the decimal point. To compare, it's usually helpful if I make sure that they both have the same number of digits after the decimal point. So I can write 6.2 as 6.20. That is the same thing. Right, we just stated that previously. So now we have two digits after the decimal point for both numbers. So now what I can do is compare those decimal components. So 20 is bigger than 19. So 6.20 is bigger than 6.19. So we can use the greater than symbol to show that 6.20 is greater than 6.19. And again, that's because 20 is bigger than 19. Now what if you had 4.7 and 4.7001? Again, make sure that when you compare, they have the same number of digits after the decimal point. So over here, we have 4 digits after that decimal point. For the first number, we only have 1. So what I want to do is add zeros to that first number. So now we would have 4.7000. So now we have 4 digits after both decimal points. And now we can compare the numbers after the decimal point. We have 7,000 compared to 7,001. Well, 7,000 is smaller than 7,001, so 4.7000 is smaller than or less than 4.7001. Now lastly, we need to know how to round decimals. The rounding process is exactly the same as without decimals. So for example, if you had 1.45836 and you were told to round to the nearest tenth. So you're rounding the 4, and to round, we look at the number before it. Or I guess technically after, okay? So we're looking at the 5. So the 5, because it is 5 or bigger, the 4 would round up to a 5. So that's going to be 1.5. And typically, without decimals, we would add zeros after the number, but there's no need with decimals because the zeros at the end of a decimal point does not change the value. So next we can round to the nearest hundredth. So the 100th place is this 5, and to round, we look at the number after it. So we look at the 8. So the 8 is bigger than 5, so it's 5 or bigger. So therefore the 5 would round up to a 6. So my rounded answer would be 1.46. Next we can round to the nearest thousandth place. So the 8 is the thousandth place, and to round, we look at the number right after it. So the 3 is smaller than 5, which means the 8 would stay where it is. So my rounded answer would be 1.458. And then we can round to the nearest 10,000th place. So the 10,000th place would be right here, and to round, we look at this number right after it. So because the 6 is 5 or bigger, the 3 would round up to a 4. So this would become 1.4584. So in conclusion, we have learned our place values for decimals. We've learned how to write decimals in different forms. We have learned how to convert from a decimal to a fraction. We've also learned how to compare and order decimals. And we've lastly learned how to round decimals. And that concludes our lesson for today. We will see you next time.